Now that we've got a pretty good understanding about how polynomials work, we're going to actually try to do some modeling with polynomials. So we're going to look at an example of an application problem that involves a polynomial function. And in particular, given information about a quantity along with a constraint that helps us get us down to just one variable, we're going to determine a polynomial model for that quantity. And if that doesn't make any sense now, hopefully it'll make sense once we actually do the problem. So here's the example that we're looking at. Suppose you're using 300 feet of fencing to create a rectangular fenced-in region in the middle of a grassy field. Say you're trying to make a little pen for your dog to run around that is as big as possible, and so they don't run away. So you get to choose your dimensions, and you're interested in the area of your fenced-in region. So if one of your dimensions of your fence, in other words either the length or the width, is x, what is the area a of x? So first we're going to draw a picture. That is my very sophisticated picture of a rectangle. Thank you very much. Now remember, one of those dimensions is going to be x. It doesn't really matter which one for now. We're just going to call that one x, right, the base. And then if we're looking for the area, another quantity that's going to be important to us is going to be, I guess we'll call it y. We don't know what y is, and it's a little bit uncomfortable bringing in a new variable, especially since our area will eventually have to be down to one variable. But right now, we kind of don't have a choice. We don't know what to do. So now that I have those two dimensions, at least now we can figure out a formula for the area. The area is just going to be your base times our height. That's x times y. Now that's not quite what we want, right? Because we want to make sure that we can write our area in terms of one variable. Also, there's a big piece of information that we haven't used yet, the fact that we have 300 feet of fencing. That is going to be relevant later on. All right, so question is, how do we use our additional piece of information to get our formula from two variables, x times y, down to one variable? Well, here's our x and here's our y again. Now let's look at how that relates to the amount of fencing, because the amount of fencing is the amount of fencing that we're actually using to create that rectangular area. And also, we're using four sides of that rectangle to create that area. There's that x there, the one that's above the x below, because again, this is a rectangle, so the opposite sides have the same size, and that y that's across from the other y as well. So if we want to look at the length of the fence, we can actually look at that from two different perspectives. On the one hand, it's 300. That's how much fencing we had to make it. On the other hand, if we use the setup that we have in that picture above, the length of the fence is just adding up all the lengths of the sides of our fence. So I'm going to go clockwise from the top, x plus y plus x plus y. And we don't have to simplify that, but I think I will. It might be helpful later. That's going to be 2x plus 2y. Now, since both 300 and 2x plus 2y both represent the exact same quantity, the length of the fence, that means they have to be equal to each other. And that allows us to solve for one of the variables in terms of the other. And since we want our eventual formula to be in terms of x, I'm going to solve for y. To get 2y equals 300 minus 2x. Then if I divide both sides by 2, I end up with y equals 150 minus x. And the nice thing about that is, remember, our area is x times y. Since y is equal to 150 minus x, I can substitute that into my formula. And when I do that, we've got it down to one variable, just x. Now we can keep it there if we want, but I can't help myself. I gotta simplify. I got the simplification disease. Sorry, hope nobody catches it. It's not like COVID. So if I multiply out that x, I get 150x minus x squared. And so my a of x, I'm even going to write the x squared term first. Our a of x is equal to negative x squared plus 150x. That's a polynomial written in terms of one variable. All right, so now that you've sort of seen how to create these models, you're going to have a couple of opportunities to work on some of your own. You're going to look at polynomial models on the PDF file included with this video.